Throughout the conference, we've discussed numerous ways to make your Shiny apps production ready. However, implementing all these rules and checks might seem like a lot of work and time consuming. You might think that Shiny is an ideal tool for quickly building R based web applications, but you're not wrong to be concerned about these issues. Fortunately, the next speakers are here to demonstrate how to implement these rules and checks both quickly and effectively. They'll show us how to strike a right balance between speed and efficiency and develop production ready Shiny apps without sacrificing velocity. Kamil Wais is a consultant at our 7N consultancy agency who leads a real world data insights engineering team of R&Shiny developers at Roche. We also are joined by Krystian, who is a scientific software engineer at 7N. So I'm so honored to introduce both Kamil and Krystian to the stage.
Hello.
Thank you very much. Welcome everybody on behalf of our whole team. It's really great to be here, and let's immediately start with defining the problem. We already know that R&Shiny is excellent for quick prototyping of interactive dashboards, which is obviously not the problem here. However, you might also agree that sometimes we can prototype very quickly, but moving a dashboard to production can take much more time. Let me illustrate this problem with a story and our motivation. In our daily work, our team builds complex analytical for rapid real-world data exploration and hypothesis generation at Roche. We know how to develop such dashboards, so if there is a need for a new custom real-world data dashboard, we can deliver. If there would be a single real-world data source and a single dashboard to be built, then the development would be pretty straightforward. We can develop the dashboard from scratch, and that's it. Probably there will be some maintenance or further development, but our work is mostly done. But imagine that there is another dashboard to be built, and another, and one more, and many more. Additionally, those new dashboards need to be built for some new real-world data sets with new project-specific requirements. So we start facing completely new challenges, and those challenges can be summarized as the multiplicity of everything. So we have multiple real-world data sources coming with different data models. Because of that, we have multiple projects with different stakeholders who have different needs. Because of multiple projects, we need to engage multiple developers who work in those projects in isolation. And because they work in isolation, there are multiple approaches to architectural designs and implementations. So we have this multiplicity of everything, even though our dashboards were built for the same domain. They are all based on patients' real-world data. Moreover, they share many features as they have similar goal: real-world data, rapid exploration, and interactive analysis. The most challenges of multiplicity is fatigue times 3. Firstly, we can see stakeholders fatigue as it takes too much time and resources to develop a new dashboard that is ready for production. Secondly, we can see fatigue in the developers' eyes as they are building new dashboards from scratch, so they need to re-implement similar functionalities again and again and again. And last but not least, we can also see users' fatigue as they need to relearn how to use multiple interfaces. Interfaces that are responsible for similar tasks, but are different because they were implemented differently and often by different developers working in isolation. So is there a solution on the horizon for the problem we have? There is. Our solution is to use production-ready components. Okay, but what are those? You can think of production-ready components as of ready-to-use, high-level, loosely coupled modules that do specific tasks or group of tasks very well. Additionally, they hide the complexity of technical, business, or scientific logic under intuitive, interactive graphical user interface provided for the dashboard end users. What kind of production-ready components we can extract for future reuse? Well, at Roche, we develop and often reuse in our dashboards components responsible for different tasks. There is a component for user authentication authorization with corporate network. There is a component providing a common interface for connecting with many different databases and supporting interaction with those databases. There is a component for generating synthetic data based on real data kept in SQL databases. There is another component for building cohorts of patients, and there are also others. However, there are some challenges connected with this solution, but they are of a different nature than the previous ones. Now, we need to accept without exceptions that the modular architecture is the default one. In contrast with so-called big ball of math, which is an architectural anti-pattern that lacks any kind of modularity in the design. We all have seen it, right? Always in someone else's projects, not in ours, of course. We'll be using production-ready components, which are modules, so we need modular architecture from the very beginning. We also need to add that we first need to invest resources in the development of the components before we'll be able to see the benefits of using them. But once we do that, less resources will be needed in the future projects. The scarcity of resources is always problematic, but we also have a remedy for that. We should at least inner source our components internally in our company to break developers' isolation and share both the burden of components development as well as the benefits of using them. We could also do one further step and open source the code. Our team has already done it for some of our components, and we are going to open source more of them in the future. At the end, we can reap long-term benefits from using the production-ready components. As our production-ready components will be well-tested, have long life cycle and long-term support, the users will be seeing familiar interfaces of trustable components in the both old and new dashboards. The components will be easily customizable and adaptable to different projects. Our developers will be able to focus on new project-specific needs rather than trying to re-implement what was already done before. And as our production-ready components will be easily reusable, both the prototyping and moving dashboard to production will be a much faster process. Stakeholders will be able to see the first production release much quicker, and in time, it will also take less resources to do that. So we can quickly prototype, but then spend more of our resources on productionizing dashboards, or we can use production-ready components in our early prototypes and develop dashboards that are ready for production much quicker. Thank you for your attention. I hope I convinced you about the collaboration on open source components, but if you are still not convinced, I will let Krystian finish the job by showing them off some of our components in action. Krystian?
Yeah. Can I ask you to show my my screen now? Oh, yeah, it is. Can you hear me? I think you can.
Yeah.
Okay. All right. So as for the next stage, as for the demo, I'm gonna show the live coding because it's always a good idea during the conference. And I'm gonna show how do we use these production-ready components to develop the dashboard. Usually we start with a basic template of the application. We store these templates in our GitHub, local GitHub, and you can easily start the repository with clicking one button to create the repo and the initial structure. Then you quickly modify it, like renaming, for example, the name of the project. You can add some initial content or fill in the description, because as you can see, we're developing the dashboards in a way, Shiny as a package way, yeah. So after we create the repository, we can run the application, see how does it look like, the basic one. So as you can see, we're using the BS4 dash layout. It already has some about session ready. And now the next step when we start building a new dashboard is to generate fake data. And in the past, it was our biggest struggle because it's not an easy task. And why do we need the fake data? Usually we work on medical data, which is confidential, and it comes with some limitations. The first main limitation is that we cannot use the data for tests. We cannot present it in the internal demos because somebody cannot see the data itself, shouldn't see the data itself. And the second problem is that sometimes we cannot even pull the data into our local environment. So for this case, we've developed a tool named Data Faker. And how Data Faker works and why is it so cool? So it assumes that you store the definition of your data in the YAML format. So this is the YAML representation of SQL schema. You can see we describe here the tables, its columns, along with some metadata related to each column, which will be used to simulate it. So for example, we can, as of the metadata, we can store range to limit the range of the simulated data, some ratio of the missing values, some specific values from which we should generate it, or even provide a custom formula that stores the R code to generate non-standard column. And the main advantage of this approach is that this configuration is easy to maintain. So it's easy to modify the YAML file. You can see everything here, and you can easily share it with between the projects. Yeah, always very frequently we work on the same data. So in order to have the same data generated, we just share the YAML file. Then you just run a few lines of code, and the data is here. Yeah. Of course, it's also not an easy process because we need to consult the rules with the experts according to their knowledge. But once we have it, it's very easy. All right, and for the next step, it's time to develop the another views to our Shiny dashboard. And it's also pretty easy, keeping in mind we're using BS4 dash structure, BS4 dash framework. We just add new script with the new view, providing the definition for the menu item on the sidebar, the content as a tab item, and some server-side logic. Yeah, and then we place it in the proper places in the UI part of the application, for example, here, and call it in the server if the server-side logic is applied. Okay, so we've easily added another view. Now it's the time to provide the content for such view. And as you can see, we will be presenting the patient's timeline. And for this case, we will be using one of our analytical modules. Analytical modules is a set of packages, R packages, that store the logic for generating the result. Yeah, for generating, for example, survival analysis, also the logic for rendering the output, and each result is returned as a Shiny module. So for this case, we will be using the module named Shiny Timelines. I already have it here. As you can see, it's loaded. We just call the module in the UI part. We do some preparations regarding data and call the server-side logic of the module in here. And we already have the view implemented, so it's the next step is to only run it, yeah. And as you can see here, we've got the result ready. We can explore how the treatment lines across patients looked like. We can add some more information, some visits types. We can apply some ordering and so on. All right, so as you can imagine, having many such components tested across multiple applications does the job. Okay, so the next step and very common feature that we need to implement in our dashboards is to allow the users to filter the data, to provide some inclusion-exclusion criteria. And for this case, we've also developed a tool named Cohort Builder. Cohort Builder is a package that provides a unified API for filtering and managing the data. It's quite general. It allows you to write additional extensions to the package, and some of the extensions that we've already built is Cohort Builder DB. And so Cohort Builder itself operates on the list of data frames. But if you want to move your computations to the database directly, you can install the extension Cohort Builder DB, and with the same API for data management, for example, data filtering, you can just move your computations in there. Another extension for Cohort Builder is a package named Shiny Cohort Builder, and it's just the graphical user interface for the Cohort Builder API. So you can easily apply the filtering panel in your Shiny application, what I'm gonna show you pretty soon. So how do we use this Cohort Builder? At the beginning, we need to define the source, and the source defines the data you want to operate on. It can be the list of tables. It has a specific class TB list, or it can be, with using Cohort Builder DB, it can be the list of tables stored in the database. What's more, you can define some data relations, which will be really useful in terms of further operations, some source code, which is the initial point for generating a reproducible code that Cohort Builder also offers. Then after we have the source ready, we need to create the cohort object. So this is another object that is responsible for performing operations on the defined source. What's more, for the cohort, along with creating the cohort, we can define some filters. And filter, the package offers a few types of filters, for example, discrete one for the discrete data. Along with the type, you need to define the data set the filter is related to, and the variable. Yeah. So another types is, for example, filter type is date range or range for the numerical data. Having the filters ready, we can use Shiny Cohort Builder to apply the functionality in our Shiny. So looking at the UI, we are placing the filtering panel in the control bar of BS4-framework. Yeah, it's called over here, and the same happens in the server. After you create the cohort, you put it into the CB server function. You can provide some, you can define some arguments that define the functionality of the panel, and now it's just enough to run the application and see how does it look like. So let's open patient's timeline. The filtering panel automatically opens. You can start providing the filtering rules. So let's say, for example, filter by gender or filter the specific treatment lines. You can, after clicking Run step, it recalculates the data, shows you the output on the filtered out data sets. What's more, it comes with some extra features. For example, very important one in our case was to provide reproducible code that you can just copy into your R script and generate the same data as it's visible here. You can look at the attrition of the data, so the changes across filtering steps that comes with the data. Speaking about steps, you can perform multiple steps filtering. So after I click Add Step, it will generate another filtering step based on the previous rules. So you can see we've got limited data over here, and continue your providing your inclusion or exclusion criteria. So this is how the Shiny cohort builder looks like, and it allows you to implement the data filtering pretty fast. Also, if you use Cohort Builder DB extension, you can move your computations directly to the database instead of using many resources in your Shiny server. All right, and for the last step, we need to style the application, because we want our users to look at the consistent dashboards and the dashboards that follow the branding of Roche. For this case, we've implemented internally package Roche identity, which allows you to apply Roche branding to Shiny dashboards. But for this case, I've extracted part of the function of its functionality to the separate script. As you can see, it generates the CSS with styling rules using fresh package. After we run the script, it generates the CSS that you can use in the dashboard, and this is how the final result looks like. So with this, we could quickly implement the dashboard using production-ready components, and we spared a lot of time. So now we can, for example, focus more on some custom requirements that the user need for the application. And that's all. Thank you.
Thanks, Kamil and Krystian, for going through a lot of content in very limited time. I hope I'm not muted.
No, you're not.
And I particularly loved how Krystian managed the demo, and by checking out different versions quickly and sharing so much, I'm definitely going to steal that idea. And this is definitely one of those talks that people come back to, and I'm sure everyone would love to have a look at the repo. We do have quite some questions, so we can dive right into it. Joe Chang's definition of production is roughly that it is relied on by real people with real consequences when things go wrong. So, do you agree with this definition of production?
Kamil?
Sorry, I was hearing you better, but also copying and pasting the links to the chat. So
sure. Let me
I
ask
don't know
it
if I
again.
got it correctly.
So,
yes, the definition
Joe
of the
Chang's
production. Yes, can you repeat?
Yeah. So Joe Chang's definition of production is roughly the application that is relied on by real people with real consequences when things go wrong. Do you agree with this standard? Or do you have some other definition for production?
Well, yes, it's well, yes. I don't see why we shouldn't agree with that. And this is also motivation. So to make things in a way that when real people will be using them in settings in real world, they will be working. And if you have something which is tested really well, and it's reusable, and it's trustable, and it's supported, then you increase your chances of having something in production that will work, right? I don't know, Krystian, if you want to add something.
Yeah, actually, it's worth to think about when did we start to name them as production ready. Yeah, and the story for generating such tools was long, and we also came with some struggles. We deployed the application and we had to quickly fix something, and throughout the time we finally managed to generate some workflow or some rules that we can finally conclude that okay, this dashboard is ready. But it was always based on the users feedback, and actually the users themselves are the best testers. Yeah.
Okay. Uh, Stephen from the chat asks, when you move computation to database, is it only for database like computations like filter, sum, group by, etc., or can we move more complex R related tasks?
This is a good question, and it depends on the cases we've had. For example, for this Shiny cohort builder, when we were working on the tool, it was very important to us to not pull any data at all to the server. Only the final statistics, only the parts that are visible to the user. So in this case, we also had some challenges. So, for example, rendering the histogram for the data, if you don't have the data itself, can also cost some time. So, for example, it was very challenging for generating histograms for the date types in the database. We had to somehow compute the blocks, the statistics, how many observations are there in the limits, and it came with some non-standard SQL queries. Yeah, so I may answer that. Yeah, both actually pretty simple tasks, but also very complex ones.
Awesome. Do you have any
I
suggestions?
can just add to that I think.
Yeah, please go ahead.
Sorry. I think that the very got it. The very powerful feature of moving the filtering and subsetting the data and building the cohorts of patients on the database server side is that you don't need to do it in memory. So you don't need to pull the data into the memory. You don't need to process it in the memory. You just do it in the environment that was built for such tasks, right? And if you have data that have gigabytes of terabytes of data, that is the only thing you can approach this. But you can still approach it with the same tool. Just you can add another extension to it. That's, I think, it's important here. Thanks.
Awesome. Thanks for elaborating it. Do you have any suggestions for Shiny developers who find challenging to work with IT teams in particular? I see that there are different skill set involved and communication can be challenging. Do you have any suggestions for it?
Kamil?
Thinking. It's a difficult question, I guess. It can be tackled, I think, from different perspectives. So we can think, we also work with people with different skills. Sometimes we are working with stakeholders that are programmers themselves and they can prototype things and we are just helping them. Sometimes we are working with people that are just junior developers and they are starting learning something. So I guess it's very difficult to give one solution that fits all possible cases, but maybe just sharing the good practices. Like we are trying in this case sharing the components, like we are building what we are encouraging people to contribute to and to reuse them. So we can also share our skills, our know-how, our experience, do a little bit mentoring from time to time, code review. I think that many possible solutions to that. I have some golden one from myself. Krystian, maybe you want to add something?
Actually, you've said everything. Yeah.
Yeah. Thank you, Kamil and Krystian. It was great talking about these topics. They don't get a lot of attention, but I'm hoping that everyone will look into the GitHub repository and understand about production quality applications with this talk. Thank you so much. See you next year.
Thank you.